All right. Hello, everybody. Yeah, thanks everybody for making it here at this kind of crazy hour of the morning. My name's Paul Annesley. I'm leading the distributed systems team here at Culture Amp. I've been working in tech for quite a while now. But I still remember the excitement of splitting out a microservice for the first time. Yeah, I was working in the early stages of 99 Designs around 2008, and we decided that our payment system should be a separate service. I'm pretty sure that very same service still haunts them to this day. So it's kind of a, yeah, that was a yes over there. So sort of a mixed success there. It was a service we split out. It was useful for a decade, but it certainly wasn't smooth sailing, and we learned some things from that. And then into Culture Amp. When I joined last year, Culture Amp had been juggling microservices and Monolith for several years already. So I want to share some of the experiences that I've learned along the way. So today I'll be discussing just briefly, what do we mean by Monolith and microservice, why you shouldn't build microservices, why you probably eventually do it anyway, and one way to integrate them into your system that's worked for us. So, simple one to start with, what do we mean by monolith? For our purposes, we just mean you've built all your functionality into a single web application. It's pretty clear when you've got a monolith. It's not necessarily a bad thing. Onto microservices, it's a bit more complex or a bit less agreed upon. First of all, I would say don't worry about micro. There's all sorts of rules that people have made up about, you know, whether you can feed your team with 2 pizzas or whether you can rewrite it in 2 weeks. I don't think any of that really matters. The main thing is that microservices are smaller than your monolith. And the reason for that is that they've got limited responsibility. They're just performing a subset of what you need your system to do. For example, you might have a login page and login service, and that's managing your user records, but it's got nothing to do with the rest of your system. And so microservices, they should be independently deployable. Easily replaced is what they're often described as. Put that in scare quotes because like rewriting anything is not easy, but it's easier than replacing the rest of your system. They come with a lot of trade-offs, and I'll talk about some of those in a moment. And I'm pretty sure they breed. So you start with one and it kind of spirals out of control from there. So to elaborate a bit on why you shouldn't build microservices. Basically, they're expensive, they're difficult, and they come with a whole set of new problems. You're going to sink a lot of time into building them and running them. There's more to build. You end up with multiple code bases, multiple applications. You've got to maintain each one. You've got to understand each one. Everyone you hire has to understand them. There's a lot more complexity in how they communicate. You end up with a lot of them, and they need to talk to each other and share data, and that gets difficult. And you end up less certain about where your data and where your functionality actually lives, which can make day-to-day building of features kind of difficult. A microsystem sort of architecture is much harder to test end to end. You know, you can't just fire up your Rails RSpec or Cucumber tests and, you know, assert that your system's working. There's a lot in the interconnection between all the services. And it's really difficult to choose the boundaries correctly. So, you know, the idea is that you're slicing up your monolith into, you know, bounded contexts that make sense. But figuring out those boundaries, nobody really gets it right the first time. So it's a long process. There's a lot of other reasons. If you Google, you know, should I build microservices? You're going to see a lot of things saying, no, don't do it. But at a certain size and complexity in your organization, there's some reasons to use microservices that begin to emerge. And we'll go through some of those. So first of all, if you're stuck on a language or technology, maybe it was chosen a long time ago, you might find it difficult to build. You might find it difficult to hire for. And using new technology or new languages to build your new features could be something that microservices helps with. With microservices, you can independently deploy, scale, measure, and optimize. This really doesn't matter early on when you've got a few people working on the core of your business, but as things get more complex and more distributed, it can matter a lot in terms of development speed and also spend. Microservices help you decouple unrelated components. So if you find that your app is slow to start up because it's loading 3 YAML libraries and 7 HTTP clients, chances are you're in a Rails monolith. Microservices, on the other hand, they tend to have smaller sets of dependencies, and you might end up with 7 HTTP clients across your organization, but hopefully only 1 or 2 in each code base. So it's an improvement. PCI DSS, SOC 2, GDPR, these are all horrible acronyms that relate to compliance and security certifications. They're something you often don't need early on. But again, as things get more complex and you're dealing with sensitive data, you find that you do need at least some of these compliance levels to do business. And it can really slow you down. It slows down building software, it slows down running systems. And one strategy to deal with that is to isolate the parts of your system that are dealing with personally identifying information and payment information, things like that. Get them off into their own microservices, and yeah, those ones are going to be difficult to iterate on. But then your sales funnel and your landing pages go nuts. Just get them out of context of your compliance. So that's a reasonably strong reason. I don't think any of these reasons on their own, maybe even combined, are strong enough to really think about splitting your nice simple monolith into a bunch of complexity. But there is one reason that's really strong, and that is to empower multiple cross-functional teams to build your product. So small independent services can be built more easily and operated by small independent teams. When you start doing this, you find engineers on a team, they understand the entire service that they're working on. And when new hires are brought in, they just have to learn that one part of the system. So they get up and running faster, more people understand the full context of what they're working on. Often you bring someone into a monolith, you get them working on a feature, and the next day they're running into this weird code in some other part of the system. They're not sure if it relates to what they're working on. That's something that microservices can help with. As a result, cross-team communication, which is a lot more expensive for an organization, it ends up being conversation relating to well-defined APIs rather than implementation details. And that's really important, that your teams are talking about how should our components fit together, and not sort of arguing about how to build them or whether we should be using tabs or spaces in the code base. All of this kind of relates to Conway's law, which most people have probably come across. What he said is, he said it in a few different ways, and there's different quotes floating around, but any organization that designs a system, they'll produce a design whose structure is a copy of the organization's communication structure. So basically it's saying, you know, you split apart your teams, they're going to design something where team A is building a piece over there, team B is building a piece over there. And it's partly an observation by Conway quite a long time ago of just an inevitable outcome of splitting apart teams. But it can also be used as, well, we can optimize for it rather than fighting it. So if you've got multiple cross-functional teams and at a certain size, that seems to be the way everyone's going, then it does make sense to split apart and have multiple independent services. So none of this really matters because inevitably one of your teams is going to go and build a microservice when you're not looking, and the sunk cost fallacy says that there's no going back. You've got to roll with it. So what's one way to integrate it into the rest of your system? Here's one approach that's worked for me in the past. It's something that sort of 99 Designs, where I used to work, has had good success with, and it's looking promising here as well. So we start with a simple monolith. You know, you build a business, you build a code base, the traffic hits it. It's fairly simple. Inside the monolith, there's a bit more going on. There's, you know, auto scaling groups, there's load balancers, there's a database, but ultimately it's still just a monolith. The rest is implementation detail. So along comes a microservice. How do we make it useful? How do we start, you know, wiring it into the system? There's a few options. A simple approach is to build every service as a private API. It's sort of simple. You can imagine how you might do that. It doesn't change the traffic hitting the front of your stack. But it's a little bit limited. And I think I mentioned microservices breed. You're going to end up with lots of these things. And it's obvious here that the monolith is still the bottleneck. It's still in charge of everything. And that's sort of what you want to get away from. So the other option is building microservices that are actually user-facing. So, you know, they might be serving their own HTML and JavaScript. They might be providing public APIs for your web front end or for your mobile apps. But there's a question of how do you actually get the right requests going to the right service? And the answer is, of course, another microservice. Let's see where this is going. So we call ours Web Gateway. It routes traffic, it looks at requests coming in, it chooses an appropriate service to send it to. So let's have a look at what's inside Web Gateway. Ours is written in Go. That's a gopher. So Go is a language designed by Google for this kind of thing. It's fast. It's got an extremely solid HTTP implementation in its standard library. It's pretty well suited to the job. We're running it in Docker on Amazon ECS. One nice thing about Go is it compiles to very small sort of binaries. So the Docker images that we can ship for this are about 10 megabytes. Makes it sort of really easy to get them into production. Inside Web Gateway, basically a whole lot of layers of middleware. HTTP requests and responses pass through those layers. If you're familiar with Ruby and Rails, you know, Rack is an example of a middleware system. Kind of same idea. Every request goes through every layer. comes back again. And every layer has the opportunity to respond to those requests. So the first layer is ingress, just fancy way of saying it. It receives HTTP requests. The first interesting layer is logging. So every request comes in, the response comes back. You get to see what was requested, how long it took, what was the response code. So we stream these logs to Amazon CloudWatch, and then from there we can relay those to Splunk. Different people use different sort of log aggregators, Papertrail, whatever works for you. But it's really nice having something right at the front of your stack. So no matter how much you split up services behind that, you can see all the traffic coming in one place. On a similar note, metrics. That front of stack is a great place to capture metrics on all the requests and responses in your system. So we're sending custom metrics to Datadog, and they turn them into pretty graphs. And from there, it's easy to drill into different aspects, including looking at particular backends and saying, just show me the traffic for this backend. Is it slower? Is it faster than the rest? Is one of the backends, one of the services, responding with more errors than the others? It gives a lot of really good insight there. Filters and redirects. So this is a bit of a catch-all. Because this is just a program, it's written in Go, and it can respond to requests and responses. It means you can write any logic you want in there. I would say complex business logic really doesn't belong there. But for example, enforcing HTTPS, it's a perfect place to put, sort of stack-wide logic that you don't want to reproduce in every microservice. And that really helps you pull out complexity and keep the services small, because they don't have to deal with the trivialities of validating requests and redirecting to HTTPS. Authentication is a big one. It's one we're actually still working on, but it's one of the biggest challenges when you're splitting apart a monolith into user-facing microservices. So you don't want to be re-implementing authentication in each one, and you don't want a user having to sign into each one separately. So Web Gateway or a similar service at the front of your stack, it can work in conjunction with an identity service to enforce authentication as the requests come in. And then we can inject an RSA signed JWT that represents the identity or lack thereof of the user making the request. And then the services behind it just have to have a very simple implementation of look at the JWT, use a public key to verify where it came from, and then not have to implement the rest of the authentication system. And finally, routing. Different request paths go to different backend services. Go has an almost comical number of HTTP routing libraries. Most of them are blazingly fast and written by clever people, and makes this easy. So obviously this is just different paths go to different services, so you can slice up your app from a user-facing point of view. So that's an overview, a very quick overview of Web Gateway and what that's made up of. Credit goes to the platform team at 99 Designs for demonstrating how Go can solve that problem nicely. They've been successfully running a really similar service for a couple of years now. Is that right? Yeah. I think also on ECS, and that's worked really well for them. It's looking really good for us. I should point out that Web Gateway isn't open source, but that's because it's basically sort of thin business specific logic around the Go standard library and some open source components. So it kind of makes more sense to build your own, put it together in a way that works for your stack rather than try and turn it into a generic framework. It keeps it sort of, built for a specific purpose. So wrapping up, introducing microservices, going back to the beginnings, it splits your system into separate pieces. Each one is smaller and simpler, but overall the system is more complex. It's not going to make things easier. The big win, it comes from aligning microservices with your organizational structure. It's really about people. It's not about technology. And wiring it up is hard. Our solution for wiring it up, or one solution, is a routing service up the front. And on the routing service, there's other options. Amazon has an API gateway service. That's kind of what the name Web Gateway is a riff on. But that's really designed for very structured REST APIs, whereas by the time you've built a monolith, you've probably got all sorts of different kinds of requests, you know, spitting out HTML or JSON or different APIs and pages. So API gateway seemed a bit less appropriate. The Amazon load balancer these days can actually route requests to different backends as well. That's a simple solution to get started, but it's a lot less flexible. Go, it's a really great language for this kind of thing. If you're building network services that need to sort of, you know, fling HTTP around your system, I wouldn't choose any other language for that particular job. It's fast, it's quite easy to work with, it's quite simple to learn. And again, the HTTP support in it is really, really solid. Middleware, so these layers of behavior that you can sort of just plug together. That's a really nice way of getting your requests processed in your stack. But for complex business logic, you'll end up building more microservices. That's the way this goes once you start. It's hard to get away from. And that's it. Thanks very much.